Welcome back, everyone. Today's lesson, lesson 97, is graphing linear inequalities. The only difference with these inequalities are that we're going to be graphing them on a coordinate plane, unlike before where we were graphing them on a number line. To get started off here, we are going to determine if the solutions that they give us in our problem are solutions to the inequality given. So for it to be a solution, it has to be an ordered pair that makes the inequality true. In order to do this, all you need to do is plug in your x coordinates and your y coordinates in for your x and y of the inequality. Let's look at example 1. If our x coordinate is 0 and our y coordinate is 4, let's plug those into our inequality. So I'll plug in 4 for my y. That has to be greater than 5 times my x coordinate, which is 0, minus 1. Well, I know 5 times 0 is 0, minus 1 gives me a negative 1. Is 4 greater than a negative 1? That is true. So 0 and 4 is a solution to that inequality. Let's look at the second one. 3 and negative 3. Let's plug those numbers into our inequality. So I have a negative 3 for my y. This has to be less than a negative 3 times a positive 3 plus 6. Negative 3 times 3 is a negative 9. Negative 9 plus 6 gives us a negative 3. A negative 3 is not less than a negative 3. So this statement is false. Let's look at the third one on this slide. Negative 4 and 8. Is that a solution to y is less than or equal to 9? In this example, there is only a y in our inequality. So I only have to use the y coordinates of my ordered pair. So I'll plug in 8 in for my y, plug in my inequality symbol, less than or equal to 9. So is 8 less than or equal to 9? That is true. So here we saw 3 different examples of where we plugged in a ordered pair into the inequality to determine if it's true or false. Next slide you may do yourself to practice some more. Example 2, graphing linear inequalities without technology. So we've already been practicing graphing linear lines, linear functions on a coordinate plane before. And we did that by doing 2 things. First, plugging in or plotting our y-intercept. Where does it cross the y-axis? And then 2, using our slope to find the second point. Remember, in our format, y equals mx plus b, your b is always your y-intercept. And your m is always your slope. And so you're going to use that to help find 2 points. And remember, you need 2 points in order to draw a line. And then when we draw our line, there's going to be 2 different kinds of lines that you can use. The first kind of line is a dotted line. You use the dotted line for those linear inequalities where they use less than or greater than. The second type of line is a solid line, and you use those if it's a greater than or equal to or less than or equal to. That means the solution can be on that line or it could be above or below that line. And then the last part, plot any point on the coordinate plane. I would recommend you use 0, 0. So you're going to try to decide which side of the line is all the solutions going to be on. Because that way you're going to have to shade in that part of the graph. So if 0, 0 is a solution to that inequality, you're going to shade the side of the line where 0, 0 is part of. If it's not, then you shade the other side. That'll make more sense once we see an example. So this first example here, graph inequalities without the technology. Y is greater than or equal to and negative 3/4 x minus 3. So I need to plot at least 2 points. My first point is always going to be my y-intercept, and in this case, I have a minus 3. So I'm going to go to my y-intercept, or my y-axis, and I'm going to put a dot at negative 3. Now my slope is a negative 3/4. That means my line is going down from left to right. So in order to plug another point on the coordinate plane, I'm going to use my slope. I'm going to go up 3, 1, 2, 3, and since my line's got to go down, I got to go to the left 4, 1, 2, 3, 4. So my point is going to be at negative 4, 0. Now I can draw my line, and you notice that I have greater than or equal to. So that means I have to use a solid line. So I'm going to draw a solid line here to connect my points. So there's my line. Now the last parts, I need to find out which side of the graph are all my solutions going to be on. So I'm gonna pick a point. As I said earlier, I would choose 0, 0. So if this is 0, 0, I want to see, is that point a solution to my inequality? All I have to do is what I just did before when I was determining if an ordered pair is a solution. I plugged in the coordinates into the inequality. So if y is 0 and my x is 0, does that make this statement, this inequality, true? So this side is 0, negative 3/4 times 0 is 0. 0 minus 3 is a negative 3. Is 0 greater than or equal to a negative 3? Yes, it is. So now I can shade in this side that 0, 0 is a part of, because everything on the line and above is going to be a solution to that inequality. So I'm going to shade in all of that. Let's look at another example. This one, x is less than 4. So here, I just need to put a line on x is 4. So x is 4, I go to the x-axis, I draw a vertical line on 4. But it said that it's less than. So I can't use a solid line. So I'm going to erase my solid line here. And I have to use a dotted line, because the rule is if it's less than or greater than, I use a dotted line. So I'm going to use a dotted line to draw my graph. This is still going to be on 4. So I have a dotted line on here. Now it says it's got to be less than 4. Now all I have to do is treat the x-axis as a number line. So if I'm at 4, everything less than 4 is a solution. Everything less than 4 is to the left. So I'm going to shade everything to the left of my graph. All of those points are a solution. Let's take a look at one more type of example. For this one, they have it in standard form. You will need to put this in y equals mx plus b format first. So in order to do that, I need to get 5y by itself. So I'm going to subtract 4x on both sides. So now I have 5y is greater than or equal to a negative 4x minus 10. to get y by itself, I divide by 5 on both sides. So now I have y is greater than or equal to a negative 4/5 x minus 2. Now I can plot my points on my coordinate plane. So again, my first point is my y-intercept, which is a negative 2. So I'm going to go to my y-axis and put a point at negative 2. Now I'm going to use my slope to find my next point. And since it's a negative slope, I know it's going down from left to right. So if I go up 4, 2, 3, 4, to the left 5, 1, 2, 3, 4, 5. This is where my second point will be. Now I can draw a line to connect the two. And again, it's greater than or equal to, so that means I have to use a solid line. So I'm going to draw a solid line here. Now I have to determine which side of the line is going to be shaded in. Well, if it's going to be greater than or equal to that line, it has to be on top of that line. But to make sure that it's true, again, I'm going to choose a point. I'm always going to choose 0, 0. So if I choose a point 0, 0, that's right here, I want to see, is that point a solution? I put 0 in for y, I put 0 in for x, and I see if that is true. Is 0 greater than or equal to a negative 2? Yes, that is. So I know that this side, everything above this line and on the line, is a solution to that inequality. If you want to work on a few problems yourself, you may pause the video and work on the next couple slides yourself. Example 3, graphing linear inequality with the technology. So here you can use your graphing calculator. So I'm going to push out my graphing calculator so you can see that here. And then we're going to solve these on here. I'm going to go through the steps on how you can show these inequalities on your graphing calculator. So the first thing I'm going to do is hit the turn calculator on, hit the y equals button. You want to make sure that plots 1, plot 2, and plot 3 are off. Now, in order to do these, you need to make sure that your inequalities are in y equals mx plus b format. So this third one right here is already in y equals mx plus b format. So I'm going to put that equation in here. So I have a 2x plus 6, and it's got to be greater than. In order to show that we're shading everything greater than that, I'm going to hit the arrow button all the way over until I'm to the left of the y1, and you'll see this. You'll see this line over here it's almost like a lever that's going up and down. That's where I want to be, and I have to determine which side of that line is the solution going to be on. Since it's greater than, it's got to be above the line. So if I go down to the enter button, I'm going to keep clicking until I see a triangle that's on the upper end. And so here you can see I have the shaded in triangle on the upper end. That's saying that it's going to shade everything to the on top of the line. Now if I hit graph, you'll see my line being drawn, and everything on top of the line is a solution. That is an example of using your graphing calculator to solve one of those problems. You may test those other two out yourself. The only thing you will have to do first is put them into y equals mx plus b formats. Moving on. Example 4. Write a linear inequality given the graph. So here they give you a graph. They tell you which side is shaded. We just need to write an inequality for it. So I'm going to start off with my y. I know it's got to be greater than, because everything is greater than, it's above the dotted line. It's on top of the dotted line. I know it's just got to be a greater than because it's a dotted line. Now I need to know my slope and my y-intercept. I'm going to do my y-intercept first. I know it crosses the y-axis right here. Since my y-axis is counting by 2's, I know that's a -4. So I'm going to put a -4 at the end here. Then I need to find another point. In this case, I can see where it crosses the x-axis. So I'm going to put a point here. And now I just need to use rise over run. So it goes up to 4 over 4. 4 over 4 is 1. And since my line is going up from left to right, I know it's a +1. So it's a +1x. And everything's shaded above that line, so that's why it's y is greater than 1x minus 4. Letter B. The line is crossing the y-axis at a -1. I don't have an x, so I'm just going to have y, and it crosses at a -1. You notice that it's got a silent line across, so I know it has an equal to part, and it's shaded below -1. So I know that y has to be less than or equal to a -1. You may do the next two problems yourself for extra practice. And an application problem. Tia will attend a school carnival and she plans to spend no more than $12. Each game costs $2 and each item of food costs $3. Write and graph an inequality to describe the total cost of the carnival. For these, we need to make sure that it's in this format. X plus y has to equal your total money. So my x is always going to be what's listed first. So they're spending money on each game, so that's my x, and each item of food, which is my y. So I would always go in order. Whatever's listed first is my x, whatever's listed second is my y. Okay, so each game costs $2. So I'm going to have 2x plus each food item costs $3, so I have 3y, and it says no more than. No more than means it can't be bigger than 12. So if it can't be bigger than 12, it can be 12, so it has to be less than or equal to $12. That is my inequality. But in order to graph that, I need to put into y equals mx plus b format. So I need to get y by itself, so I'm going to subtract 2x on both sides. So now I have 3y is less than or equal to, I'm going to put my x term first, so -2x plus 12. Now to get y by itself, I'm going to divide by 3, divide both sides by 3. So I have y is less than or equal to a -2/3 x plus 4. Now I'm ready to graph that. So I'm going to put my first point at 4. So +4 would be right here. And I use my slope, and it's a negative slope, so it's going down from left to right. So I go down 2, 1, 2, to the right 3, 1, 2, 3. I have my 2 points. It's less than or equal to, so it tells me I'm going to use a solid line. I'm going to draw a solid line here. Now I just need to shade everything on here. It says it's got to be less than or equal to that line. If it's less than or equal to that line, I know it's below the line here. But if we want to double check that it has to be that side, I can just pick a point. I'll pick my 0, 0 again. I plug in that in here. So if y is 0 and x is 0, is 0 less than or equal to 4? Yes, it is. So this side is correct. This is the side that should be shaded. That would be describe the total cost of the carnival and all the costs that it could be. You want to test one out yourself, you may work on example 5b. Otherwise, your assignment for next time is lesson 97, 6, 8, 12 to 17, 19, and 20.